Why?
Something that she was listening to, you guys.
What did he say yesterday?
I don't even know.
Was I even in here yesterday?
Yes, you were.
What was? I feel like I
Were
kind of
you
remember.
focused?
Was
I don't
it
think I
about
was
you
there.
yelling at one of the kids?
No, I should pause that.
But I feel like she heard part of that.
She might have.
What?
Joyce, what were you laughing about? Let us know later.
Or in the comments.
There's no such thing.
Right. Public comments?
There are, but we don't do them.
Not usually.
No, we just comment in class. That's our problem.
Although someone subscribed to my pre-cal one the other day.
Really?
Although she's always there, so I don't know why she subscribed. But that's okay.
Here's the thing, Miss D. I'm subscribed by my heritage, my heritage thing.
Subscribe?
Yeah, to Miss D's. But like, it doesn't show because all your videos are blocked by the school.
That is true.
Racist.
She's like so bad. You remember she called Sam Chinese? Oh my god.
Who called Sam
And then she's
Chinese?
like, when this guy, so if a guy walks into a 7-Eleven and shoots one of the guys with the big turbans on, because you know, that's what they all wear.
Who are you talking about right now?
Suck.
Sad.
The turbans? Yes, she called them. She was like, so if somebody goes into a 7-Eleven and shoots a guy with one of those big turbans, because you know that's what all the 7-Eleven people do. And I was like, okay, sir.
I feel like she's being racist just to make us laugh.
I don't. She's like, oh, I have a twisted sense of humor. But I think she meant I have a twisted sense of humor about the murder, not about the turban part.
Anyway.
Oh crap! I like
I'm
it.
glad accreditation people aren't in here.
I had trouble with 53.
They were in our meeting, and I was like, what's up?
Oh, I got that one.
Shut up. So
Oh, the student council meeting. Alright, what evens do we have in section 11.3?
42.
42.
All of them. Oh, wait, 42. Yeah, I had a question on that one. And then that's why I stopped doing it. And that's why I didn't do it.
Alright, 42, all you have to do is find y and take his derivative, find x and find his derivative.
Wait.
Plug it in, plug it in.
Yeah, not even close.
42. Hold on, listen.
Well, for all of them
One
except for
undefined, zero undefined.
the last one,
Frick yeah, I got it
you
right
can kind
first
of
time.
tell from the graph though.
Yeah, you
Or the
could.
picture, whatever. it is.
Yeah.
But it's a quick reminder of what's going on when you have a vertical tangent line, horizontal tangent line, right?
Yeah.
Okay, good.
Yeah, I don't know why.
And I think you also define r to go with the thetas, isn't that true?
Somewhat.
Okay.
Although they gave us an R.
I feel like they really simplified that much easier than I did.
Oh, I simplified it more than they did. Like, big time.
I didn't simplify it all.
And you didn't life's hard.
Wait, simplify more. There's not really much more. I mean, it's factor the top, but that's about it.
I got down to negative parentheses cosine 2 theta minus cosine theta all over sine of 2 theta minus sine theta. I got the right answers.
I don't think I would have wanted to work with cosine 2 theta and cosine theta. I think I just would have factored the quadratic on top. That would have been easier. Alright, so anyway, solve, 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 and then we're good. Keep going. 50. Final answer, pi minus 3 over 3 over 2, aka 0.544.
Slater was way off of 42 by the way.
Isn't it? Wait.
Goes from pi over 6 to 5 pi over 6, 1/2 of my r squared d theta.
Why did I do pi over 3 to 2 pi over 3?
Uh-oh. Why did you?
I don't know.
Brain,
Did I really
Hold on, double check. Did you write down the right function?
brain fail.
2 sine theta minus 1?
Yeah.
Aren't sines pi over 3? No, I must have.
Sine's going to be 1/2
I was
of pi
thinking
over
pi over
6.
6 and put pi
Yeah.
over 3. Okay.
Yeah. Because you were thinking first, second quadrants. You were just at the 60 instead of the 30. All right, number next one.
Wait, what was the answer? 544?
Sorry. 0.544 or pi minus 3 root 3 over 2. This one was totally possible by hand. Sorry. What was the answer?
That's funny.
Although, do you see how they use power reducing? You would have had to in order to solve.
Said the blind man.
Hey, P.S. With the test coming tomorrow, have we had an Endeavor quiz lately?
No.
You said that was going to be bonus.
The bonus, yeah. But question, if you don't know your forevers for tomorrow and you need to solve a power reducing by hand, are you going to have some issues? No?
You're going to be like, oh, wait, Ms. D taught us how to be a gangster.
Oh. So you are going to remember the formulas.
Well, yeah.
Okay, good. So make sure you study your Endeavors for tomorrow. That's what I was double checking.
But those are easy. It's just, I think, never mind.
1/2
I don't
one
wanna
line.
sound stupid.
Well, cosine squared.
It's not
is-
bad as long as you remember that sine squared is the negative, is the
yeah,
minus.
Yeah.
Cosine squared is the positive.
Yeah.
Yay, big man.
It's your birthday
Friday.
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 You want us to bring food?
Group chat about it later. Okay, next one.
64.
I'm pulling up the book just in case we need it. E.
Okay. 66.
D. Ooh, look at 67. Isn't that pretty? Oh.
67.
And then number 1, 2, 3, 4.
Yes. Have the quick check.
Yeah. Oh no. Whatever
Or
you did.
the end of the whatever.
Yeah.
Here it is. Quick quiz.
Okay.
Can we go over these?
Yeah. I'm pulling up the book. Let me freeze this real quick so you guys can keep checking. Joyce, pause it. I'm going to go to the book right now.
No. Sorry, movie was really funny.
Okay, this is gonna sound really stupid, but how do you factor? Wait. On number 2, aren't there 2? Oh no, it's just when X.
Shundai.
You're right. That's what it is.
Wow.
Oh, Georgie.
How dare you say that to us?
Salute to a salutatorian.
Our salamander.
Or salamander.
It says salutatorian.
Good job.
It's salut
She really
and then
struggled.
valedictorian.
I thought it was funny. That was
The
cute.
funny part is the the one
They're not like the
that's
middle
most
school?
ironic is
No,
that
no,
one of
Jorge's
them
a
won it.
freshman.
One of them won it. That would
Huh?
be so.
Jorge's a freshman.
I don't know.
The guy on the right with the long hair, he's a freshman.
Alright. Whoop! There we go. So wait, do we still have questions, anything from homework? Because that was the end, right? 1, 2, 3, and 4?
1, 2, 3,
1,
4.
3, 4, D.
Okay, anything from actual homework before the multiple choice at the end? 53? Okay. So let's start with 53. Anything else from 11.3? Okay. What page was homework on?
Page 572.
Ooh, let's not go there. Okay, so then number 53 gives us the function r equals 2, and I think we're allowed to use our calculator because it's not shaded, right?
Yes.
Sweet. Go team. So let's come back. Oops,
I
that's
just
that
feel
one.
like it would have been more efficient to not shade the ones that to shade the ones that you could use your calculator on. I think that would save more ink.
I thought that too, but then, I don't know, I guess it depends on what section you're in as to which one's more shading. I don't know.
I don't know. If I can use my calculator, I will.
Okay, so we're in polar mode. Burp, 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 burp. We're trying to find specifically, what are the directions?
Find the area of the region described.
Yeah, and it says shared by, right? So in both. So we go ahead and, oh my goodness, I keep hitting the wrong one. There we go, r equals 2. And then r equals 2 times 1 minus cosine. Have you guys put your mode in simultaneous?
No.
You might want to. Then when I graph in, I'm going to do zoom standard. What do I got?
Oh.
Ooh.
We need to do.
Could zoom in just a little bit. Maybe we'll get it.
Square. Or is it?
Do you guys see how they hit together at these points? Why is that important?
Because those are intersection points.
Yeah, but if they didn't hit together, do you guys see how their angles would be different? Does that make sense? There was one FRQ. I'll have to find it probably after the test. I don't think I have one quite that hard in the test. There was one FRQ where they did not hit at the same time, so it might be good. I'm doing the little circle with a little psh, psh, so that way we can see they hit. Nice. And they
Graphically slow.
hit. Sometimes there are intersections that look as though they probably hit at the same time, and yet they hit their different places, so their bounds would be different. But given the picture that we have, question, what or how are we supposed to find the area that's inside both?
Well, you can go from take the integral of the area from pi over 2 for the circle all the way to pi, and then add the area to 2 little humpy things.
The area inside both is this area, right? But thinking about going to the pole, at this point at the intersection, doesn't it just go to the circle? You could go all the way if you wanted to, or you could stop it at pi, I think, true? So, for r equals 2, you would start at pi over 2 and you would go to pi. For the lemmasome, or the technically the cardioid, you would start at 0 and you would go to the intersection point, and then you would add the two together.
If you were to do from 0 to pi over 2 of the circle, and then 0 to pi over 2 of the lemmasome and add those together, technically is that allowed, or would you get marked off for that? Because the area would be technically the same since it's a circle, but I don't know. I didn't do that, but I just.
For a circle, since the circle is symmetric, technically you would be okay, but if they were wanting you to set up an integral and do not solve, or if it's an FRQ where they're grading, they want to see that you know the appropriate bounds for the area they're describing. But based on symmetry, you're right, it would be correct. But visually, that would be kind of complicated to see. Okay, so that was number 53. Then we're zooming ahead to the. It's not there, is it? It's like after all this. Okay.
Next page.
Oh, 573?
No, 574.
Oh.
There it is. Right where I left it.
Okay, so which ones are we looking at?
1, 3, 4D.
1, 3, and 4D. Inside 2 cosine theta, outside the polar curve, r equals cosine theta. What's the difference of this one?
It's just it only has one thing instead of something minus something. So I don't know how they do that. So I got 1/2 times 2 of from 0 to pi 2 cosine quantity squared d theta minus 1/2 times 2 the integral from 0 to pi over 2 of cosine squared.
Okay, so I have my functions in cosine theta and 2 cosine theta.
Well,
Ooh, I have them a little backwards, but that's okay.
The 2 goes up would be a 4, and with the exact same integral, so you subtract them would be a 3.
Gerardo's just talking about how you can pull out and then simplify, since they're both cosines. One's just off by a coefficient.
Simplified it into 1 somehow?
Mm-hmm.
Yeah, so when you graph, zoom in standard. I'm going to go ahead and zoom in because that's way too small.
Okay.
I'm so happy we're done with homework for this class, like out of the book.
We have a little snail going on, right? We have one bigger and one smaller. I know you guys just talked about it, but just to make sure everyone's on the same page. Inside the 2 cosine theta and outside the r equals cosine theta, we know that we want to go ahead and grab, oh my goodness, there we go. Grab this area, right? And how do we do that? Take our full extension, I think they have the exact same angles, right? Take the full extension and then subtract the other. And if you guys notice, how many times or how long did it take for it to complete a cycle?
All the way around.
All the way around, good. So pi all the way around, so we don't have to double it if we do the pi. But then if you go between 0 to pi, you would have the big R squared minus the little r squared all times 1/2. But if you go ahead and factor out the coefficients, oh no, just subtract because they're like terms. You would have 4 cosine squared minus 1 cosine squared would be 3 cosine squared, but then there's the 1/2 weighting was the final answer.
Yeah, but it's the 1/2.
3 halves, but then they do the halfway and double it, huh?
Yeah.
Is that D?
Yeah.
Where's x is cosine squared?
Oh, no, yeah.
Oh, I didn't even look at that part. Yeah, A. Good job. I did too much stuff in my head.
Don't have stuff.
Ah!
Not enough
And then
stuff.
never mind, not number 3. Sorry.
3 is okay?
Just 4.
Okay. So then number 4 goes ahead and gives us theta plus sine 2 theta. And you were looking at letter D specifically, right?
Yeah.
Okay. What are they asking when they say at what angle theta in the interval 0 to pi over 2 is the curve farthest away? Farthest, we know that's a max or min of something, but of what?
Maximize R.
Because R is talking about from the pole, the extension out away. Not vertically, not horizontally, but in a sense diagonally. Does that make sense? So talking about farthest away from the origin, they're not saying the highest, they're not saying the lowest. Instead, they're just saying, ooh, why are you frozen? Oh, no, 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 don't freeze. So you're trying to maximize R. So who do you have for R? How do you maximize a quantity?
Take the derivative, find the critical number. See
Take
if
R
it's
prime. Good. So we just take R prime with respect to theta, because we're doing theta in between 0 and pi over 2. So we'd have 1 plus 2 cosine 2 theta that we could set equal to 0, because we're trying to find the possible relative extrema, or the absolute maxes and mins. So we could find R at pi over 2, we could find R at 0, and then we need to find R at any of the critical numbers, which would be when cosine 2 theta equals negative 1/2. And cosine equals negative 1/2 at second quadrant is the first place, right? 2 pi over 3. But 2 theta has to equal 2 pi over 3, so then we divide by 2, which would end up being pi over 3. So then test R at pi over 2, pi over 3, and 0. And the answer ends up being pi over 3 because R is the biggest there. So think absolute extrema and think relative extrema in the sense of maximizing R. So take R prime set equal to 0 and test the endpoints with the critical numbers. Gerardo.
You know what I just realized? I totally forgot to test endpoints. I just did like the first derivative test. And I got
So on an FRQ, you would have lost points. Does that make sense? So make a note to yourself. Alright. Should have been just plugging into the formula, right? Because we have x prime squared and y squared, y prime squared. Alright, we're all going to focus on the practice test because from what I've heard, we have not done much with it yet. So everybody, all distractions away, whether it's homework, whether it's phones, whether it's, I don't know. Let's go ahead and pull out the practice test. I'm closing all this stuff down. My iPad is really sad right now, so I'm trying to get him back rebooted. Practice test. What do you guys see at the very beginning of this one?
things to know and be able to do.
What's another way of my summarization of what you need to know? The endeavor cards and our notes and our examples. True? However, long story short, could you need to graph in parametric? Yes. Polar? Yes. Using your calculator? Yes. By hand? Yes.
It's disgusting.
Could there be a calculator and non-calculator part tomorrow? Yes. Okay. So for tomorrow, make sure that you guys come in during nutrition. That is my hint. Joyce, you can come in a little bit early during lunch.
I've never wanted to hear the word no so much in my life. He's got a lot. Yes to a lot of things I wish he said no.
Both same thing.
Should we do this on a separate sheet of paper? Probably.
Probably that'd be a good idea. Now the nice thing is with the practice test, isn't it? How many pages is it?
Oh, so 2, 3.
2 multiple choice, and then I think I have an FRQ over 2 at the end, right? Okay. Oh, right. I had 9, 10, 11 as FRQs. So 9 is going to be a polar FRQ-ish. It's more of a long answer. Number 10 is going to be a parametric FRQ, and number 11 is, all sorts of little things. So is 12. So, guys, even though I do like this practice test is a little bit vector heavy, so even though I'm going to have you work through all of it, and even though the answers are online, just wait for you guys to go and check. And I think I worked it out too. I'll double check really fast. Just realize the practice test is a little bit vector heavy, so you might want to just kind of peek at polar area between just to make sure you're okay before tomorrow. And otherwise, peeking at your shared folder real fast to make sure that's my working out and not someone else's. I'm pretty sure it is, though. All right, Georgie, unless it's dire necessity, I need practice test out because we're going to work on it now. Man, that book is bad today. As you guys do that, just so you don't get distracted tomorrow, I am going to pass out your last test, which are graded with correction forms. Oh, it's not my working out. It's a nice typed working out. If you guys want to take a picture of the answer key so you don't have to check it later, that might not be a bad idea. It's at the very, very tippy top. It's also in your class folder, and there are explanations to the answers down below. All right, you guys got it? Cool. All right, Joyce, I'm going to stop the recording. You probably have already given up on us.